proposal yet, but I'm getting there.
Well, the question is whether anybody of us really understands it, including Peter. So we should probably discuss it in a group. No?
Yeah, that's probably.
So that's the visualization of it?
Yeah. Hey, Peter, want to try going through your proposal again for the group?
I can try.
Slowly?
Yeah, you're going to have to go a lot slower.
Okay, right. This is really easy because it's what we've always done historically, right? I mean, it's to use concentration scenarios in the GCM. So working group 3 start. That's the balls in your court first, working group 3, which is basically that we need some sort of idealised but internally self-consistent scenario for stabilisation, climate stabilisation, or a number of them, where we've got the trace gases approximately and the land use change in it. We prescribe those in our model. It's a coupled climate carbon cycle model, but it's got a prescribed concentration. Okay, and we calculate within that the fluxes from the atmosphere to the ocean and from the atmosphere to the land. And that means you can essentially diagnose. So you go through here, you've got a concentration scenario, always did. We're now running a model with a carbon cycle. We diagnose the fluxes. You know the increment in CO2 that's been applied. You know the fluxes. You therefore imply the fossil fuel emissions that are consistent with that stabilisation scenario. And that goes back to working group 3, and they say, well, it's just not feasible to have that rate of change of emissions, or you can't have negative emissions, or you would have to do something else in here. Maybe you have to have a Crutzen up in the stratosphere or something for this period.
Peter, just a further question.
Yeah.
One could add up considerably down on your little FE graph. You could end up with bands. It would be necessarily one trajectory. It could be a width of a...
From a number of models, you mean?
Well, or with some kind of a building an error estimate.
Yeah, sure.
And so if you end up with a band, then the job will be more consistent to see which of the emission profiles are actually consistent with that.
Right.
Yeah, that's an important addition.
You can't do it from a single simulation.
You can't do a single simulation, no.
No, but I think you just use the multi-mod. That's where your
Okay.
the value added.
Right.
But nobody knows what that band will look like.
Yeah. Okay.
No, it could be all over the
Right
place.
now, so you're running this prescribed scenario. You come up with an implied emissions profile through time, and then you do another run, which is the one that allows you to diagnose your feedback. You do the same thing as this, except that CO2, as far as the climate is concerned, is fixed at the pre-industrial value. So the carbon cycle doesn't see climate change. Okay, this is an uncoupled run in that sense. Just see CO2 increase and land use change and these things. And that will imply another emission profile. And the carbon cycle feedback is essentially the difference between those two implied emissions profiles, right? You could just as well turn the problem on its head and say, it isn't about the increment to atmospheric CO2. For a given CO2 scenario, it's about the increment to the implied emissions. And if we diagnose it from the existing models, we get pretty much the same answer as we have from the feedback analysis already, I think. So that second run is basically the same run, except CO2 is unchanging as far as the climate is concerned. Now, so this loop round here could be the assessment cycle, right? So working group 3 comes up with an idealised scenario. Working group 1 comes up with implied emissions. Working group 3 works out what that means in terms of revised idealised scenarios, and we go through the loop. The loop could be an every 2-year thing.
So what would be the minimum set? Is that what Richard originally proposed? A high emissions, high impact, and one very low emission?
In terms of stabilisation?
Can we?
Yeah.
Okay.
This is. I just want to make sure I understand
Oh, okay.
what you just proposed. So if the experimental design is actually like we run a historical case up to present day, and then the present day into the future. You're talking about the future part of that.
Yeah.
So now, if we run with that second run, where we're not allowing the concentrations to impact the radiative forcing, so we're effectively doing a present-day stabilization from a physical climate sense. That climate's going to be evolving all during that run.
Yes.
Because of the past emission history. Is that what you want?
Yes, I think so. I mean, it's not the way we did it in the C4 MIP. In the C4 MIP, we looked at the feedback right from 1850 to the current day, but that involves 2 spin-up periods, right?
Well, I was wondering.
I would prefer it if it didn't. I'd prefer it if there was only one history.
I could say isn't another way to get at the feedback. I'm just this is for brainstorming, is to do a 1% per year CO2 growth. Is the same run we've always done, and use one where it's interactive and one where it's
You
not.
can do it. You can do it either way. I mean, this need to be a stabilisation scenario. It's just I think stabilisation scenarios are more policy useful.
Yeah, because my only problem is that with the changing climate in that run impact your assessment of what your feedback was.
You mean in the historical period?
Yeah,
Yeah.
the run you originally proposed, so
Yeah.
at least what I thought you
Okay,
originally
alright.
proposed.
Well, that's an important. Yeah, that's all right. That's an important point because there is a constraint on the size of the feedback, which comes down to whether you fit either the prescribed the observed CO2 for prescribed emissions, or the implied emissions for prescribed CO2. Okay. You got it? Because all right, so,
glazed over, sorry.
right, so now, if you're going to do this, then your historical spin-up should also be with prescribed CO2.
I understand that
And you
part,
diagnose the fluxes.
but there's going to be,
And there's a big error bar on the fluxes, you don't know
right,
about
but
that.
where I was going from physical climate side, there's a big implied climate change that's still sitting there in present day. I mean, we just
Yes.
did these experiments and...
Well, all right, so let's do this then. In that case, I would propose that this point here is at 1850 or your pre-industrial spin-up. Okay.
Well, I was just wondering if it's another way to get at it rather than...
Would you say
Nice working.
1850?
Or whenever your normal start point is for your model
Your
run.
Well, it should be
Pre-industrial
1800 at least.
Okay, well, they're not typically, but
1850
sure.
or
You
1860.
don't need to know.
So you have some coal already in 1830.
Yes.
Yeah, but we,
That's
you
a
know,
problem.
it's in the model error easily.
Peter, there's one disadvantage in that simulation, that you can't use the latitudinal gradient or the seasonal gradient to sort of validate the model, because you can't prescribe that. You don't simulate that.
Well, I think you still can, actually. I mean, in order to do the tracer transport validation, you would want to rerun a period of the simulation anyway, right? I mean, you wouldn't want to run with a tracer through the entire period, so it's too expensive, and you've only got validation data for more than an hour onwards or something. So I think you could do it, and then update the fluxes, actually run with interactive CO2 for that period. The model should do the same thing. And it's quite a good test of it, actually, to make sure that the experimental design works okay. If you change the boundary condition, that you're not prescribing CO2, there is an alternative to this model, right? Do you want me to bring it up, or shall I keep that?
Go for it.
This is essentially a hard reset, yeah? I mean, this basically says you will follow this line with absolute obedience.
Right.
There is an alternative where you have a restoring term, which allows you to do a bit more of this stuff to do with geographical variation. You say that the global mean has to follow, you know,
You
you
can
know,
only do that for the well-mixed greenhouse gas. You're not going to do that for the aerosols.
no, I mean, we're only talking about CO2 here, though, at the moment.
No, but the scenario is
Yes,
for
yes.
everything.
Yeah, but in terms of the interactive component, at the moment, we're just talking about the CO2 bit.
The interactive.
Yeah, for this,
Carbon cycle interruption.
Oh, okay. No, but we are designing an experiment for projecting future climate change.
Yeah.
Everything.
Yeah.
Okay.
we are, but
And so I've taken that
We're not-
curve that you draw in there to represent all the greenhouse gases and the land
okay.
use
I mean, as far as I can tell, though, we're not talking about closing a new feedback loop in those other cases, are we? I don't think we are. We're only talking about closing the carbon cycle feedback loop at this
That's
point.
correct.
So those problems are all the problems we always had, which is how do you deal with the fact that different models get different indirect radiative forcing.
But if you're going to so there might be some models that have interactive chemistry in the core
Yeah.
that are running.
Yeah.
So I was trying not to give them wiggle room. I want them to run the same concentrations that we do for the core. For their research, they can do whatever they want.
For this long-term runs, it would be mostly, I would say, methane and aerosols. I don't think the other gases are involved. So, what you would look at, if you want to look at
You have
feedbacks,
CFCs, you have everything.
yeah, but if you look at really beyond 100 years, I don't think the other ones are that important. I'm not sure.
Well, Ozone will be.
CFCs are supposed to be phased out at this time.
Well, the ozone will be.
Yeah, but this long-term trend, I don't know how we can design it. Ozone to replace a scenario. And the feedback you are expecting from it.
I think with the chemistry.
Until 2050, I'm okay, but after 2050, I don't.
I mean, I
I'm
think
not
with
sure
the chemistry
which
it's harder,
take
isn't
into
it? Because
account chemistry in this.
I was just trying to make sure that.
Except methane.
Yeah.
Yes,
Methane
I
is-
interrupt you. You keep making.
okay,
your
now
proposal.
for the okay, there's an alternative to this hard reset, which is basically you have a restoring term, a bit like we would have with SSTs, you know, for Haney forcing, and you have something like, you know, you do allow CO2 to change, or you have a restoring term. The CO2 evolves, but it's also got a strong restoring term. Where this is the CO2 from the model, and there's the reference CO2, which is your profile here, and some timescale that we could choose, right?
What one? A year? 10 years?
10 years.
Somewhere
Could be
between
10.
those two.
Could be 10. And that would work more obviously for the chemistry, I presume, right? Because you allow some consistency in the model. Without getting strict.
What about aerosols?
I don't think you can do anything like that with a short-lived species.
Yeah, aerosols as well. There's some bugs about that.
Chemistry is just hard.
First idea better.
You just describe it. Well, the
Yeah.
advantage of this is that we wouldn't have to wait for these guys to tell us that the scenario was unrealistic, because there would be some models where, even though this restoring force was quite big, because the fluxes were nowhere near consistent with it, they'd go off here,
Yeah,
okay, and they'd overshoot on their own. And we could choose this number so that we could almost immediately say, well, that's a pretty crazy scenario for this model, but that's the way it is.
But see, again, if you're using these same runs for projections,
Yeah.
you wouldn't want that because the radiative forcing would be like that.
I think radiative force is going to be different. Well, it's going to be a little bit different anyway because of the aerosols, isn't it?
That's one of the things that if you do the CO2.
I think in the end, sure, I think we have to see this as even though it doesn't translate to the same thing in all models, we have to see this as a CO2 concentration stabilization problem, right?
Yes.
Otherwise I think it just gets too hard.
So I don't like the second way very much. I like the first one a lot better.
All right, it's easier, the first one's easier.
Because it's, like I said, at least the way I would think of it, you're going to be using the same runs as projections, or at least an evaluation.
Yeah, okay.
There's not going to be another set of runs somewhere around that are projection runs. That's all I'm saying. These are the projection runs that we're talking about.
I mean, I like the first step of it because I think you want that anyways to compare, models with the same force, same radiative forcing sort of. But I still have the lingering problem. I don't know any way around it that these scenarios that are quote unquote stabilization are not going to be stabilization as soon as you put them in these Earth system models.
They're forced to be.
What?
They're
forced to be.
follow
First
that.
one is
You're prescribing concentrations, not
No, but in the
emissions.
second step, you're going to run with interactive carbon cycle.
No,
No, so that was how I misinterpreted that.
that isn't the implication at all. I mean, in these two runs, both runs are forced to follow this. The realism of following that is really determined by the diagnosed emissions. Yeah. In this case here, for this particular model, it says the emissions have got to be negative for a significant period, and we could say, well, that's a nonsense. With this model, you couldn't stabilise on that pathway unless you did something like put sulfur in the atmosphere.
And so how does that then affect, what do you do with that feedback in the second run?
Well, just diagnosing the feedback is the difference between the diagnosed emissions with and without climate effects on the carbon cycle, and that will be equivalent to running the experiments within the C4 which is where you let CO2 go free and you keep the emissions the same, except that it's more bounded and you involve communities that haven't got carbon cycles and all of these things, and it's about stabilisation, which seems to be
Well, I mean, it's a diagnostic of what difference it makes.
yeah. Now, okay,
What's new?
Yeah.
That's what I like this
that's-
proposal because it allows a wide suite of models to run it.
Yeah.
That's what I like most about it.
Yeah. It's not really in the spirit of Earth system modelling, but there you go.
No, it's not.
I guess maybe I understand it less well than I thought I did. I mean, at some point you need a gridded, emission scenario. And you have no guarantee that when you stick that in, it's going to work.
Somebody else is going to supply us with a gridded concentration scenario.
To start with, yeah.
Okay, to start with that. But at some point you got to get back to the emission scenario.
That is somebody else's job. That's what I like best about that.
In this scheme, you get to emission scenarios twice at the beginning,
Right.
with the original input,
And the revised.
and then it's all done revised, and that can be gridded as well.
But
At least with the models that
we
can
would need
grid.
it gridded here. The CO2 we need gridded.
But we would need land use.
The land use needs to be approximately consistent with the implied
Yeah.
demonstration scenario.
Yes.
And it needs to be gridded.
And it needs to
How are
be-
you going to get the land use? I can see you get the land use consistent with the emission scenario. I don't know how you're going to get it to be consistent with the concentration scenario necessarily.
Well, in a sense, there is an assumption about how the carbon cycle is going to behave from the last way through this loop, right? I mean, the models they will use will, to some extent, be informed by last generation carbon cycle models.
Well, with the simple models.
Yeah. And then we will revise it, and every time we go through this
We'll get
assessment
better,
loop,
hopefully.
we should converge.
Yeah, so there's no
Some-
guarantee of convergence because by the time you get to the next step, you now have a new generation of Earth
Yeah.
system models that have
Sure.
new features in them.
Yeah, sure.
And so,
But in a sense, that's no different from the problem we already have, which is scenarios that developed taking account of the sensitivity of the climate to greenhouse gases that have then been revised subsequently by new sets of simulations. So that's no different, really. It's just that we're giving more information out of the models, which is to diagnose emissions.
Well, there is another feature to this proposal that I think is worth highlighting, and that is it comes close to this notion of what the emissions group calls modeler's choice. There is guidance of what you're supposed to do, but it's not too strong of a straitjacket for either of the modeling community.
We just have to try to make sure that that fits the definition of catawise.
That's your problem, fortunately, not mine.
Not necessarily. Not necessarily.
I'm just joking.
But so from
Okay.
just to play it out for 1 second, from the emissions modeling perspective, all right, so we do this sort of feedback loop. At what point does it become, where does the creativity on the emissions modeling, the modeler's choice aspect get to come in?
Well, I think there are a few components. I mean, the most important one to me right now would be how realistic are our integrated models once you account the carbon cycle in climate models as well and the feedbacks. So, first of all, did we do this approximately right? That's, I think, an important issue. And the second one would be to refine the land use models vis-a-vis the climate feedback, because that's where we have the highest uncertainty. So I could say, I think one can argue those are two of the most important things, but there may be others, like emissions trajectories, because we get some more information
if you
on the
used all the
implied
models,
emissions trajectories.
Sure, you'd get an envelope of future emissions.
So that's class number 3 that we could check.
Okay, so we're going to get to revisit this probably N times
Yeah.
this afternoon when we present it to everybody, and then probably tomorrow morning again when we do the summary, because it'll keep coming back.
Yeah. But I think it would be good.
No, it's really important because this is going to be the basis now, the rest of our discussion about what scenarios we want to run.
Yes. I would like to propose that by tomorrow we also write, or day after tomorrow, a short document that can be circulated within both communities on an informal basis, just to get additional feedback on the idea.
Peter, can you
No.
please? Pretty please?
Teach you to try to help.
I wasn't trying to help.
There's no good deed goes unpunished. This is deep and no good deed goes unpunished.
I'm having an apple.
I'll buy you a beer.
Drink more than one.
Yeah, that's definitely more than one.
It's more than one, yeah. All right, let's go back and we started the discussion on the scenarios. First thing we started our discussion, Richard proposed a high and a low. We started talking a little bit about the high. So we want to go back to that discussion?
Yeah. We can, except that I can't find my original email, but it doesn't matter, I'll have to make it up. Because as far as I remember, we had, let me see this. We had basically we had one image 5.3 watts per square meter scenario, which is very high scenario. Then we had higher baselines. We had an A2, and we had the, I think, the MIT baseline, which was definitely also in that region plus. So there were at least three baselines in the scenarios that we provided that had that would be testing that higher bound that Richard was talking about. And on the lower bound, there are another three scenarios. There was a message 3.2 watts per square meter, image 3.7, and image 2.9. So we had three choices in the low case.
3.2, 3.7, 3.9?
Yeah, 2.9. That was the lowest. And so there are at least three basic choices on the top of the scale and the bottom of the scale. In either case, at least one or two of the scenarios would be consistent with the SRES derivatives, if that's desirable.
Which it is.
Updated.
It's got to be.
I think so too, because that way you have a controlled experiment compared to the old runs with the changes that occurred in the meantime.
It's critical.
Yep. So that's already in the set that we have provided, but I'll have to, when I go into my room, I have to look in the detail.
Okay.
And these have got concentration scenarios unpacked, have they?
All of these scenarios were provided with both concentrations and emission profiles.
Okay.
And actually many of these modeling groups provide delta T for whatever that's worth.
Right.
You could
We don't really
TCM.
It's worth, actually, at some point, it's worth somebody comparing them.
Yeah. Well, I think that's the whole point of the
Part
exercise.
right,
yeah.
part of the diagnosis that we get out of it.
Although there is some,
But it sounded like we could do that now in AR4.
although there is some self-referencing here because many of the models are using MAGIC, and MAGIC was due to the climate models. So
The old ones, right?
the old ones, exactly.
What would the process be to arrive at two of those? One each, a high and a low.
Well, my guess would be, while the AR4 is still going on, I think we should start that discussion, continue this discussion in working group 3.
Right, it should
Now,
be,
while we
if
are
it
at
can
it.
be built into one of the working group
Yeah,
3
based on this
chapters.
original proposal, we can end up with that recommendation in the chapter if that's
And
what
then
the
you can
community
do it in this
wants.
technical paper, by bringing the two
Yeah.
communities together and making a joint decision.
Well, there is a step in between. It goes to the expert group, right? It goes to the expert group and then into the technical paper, and then it gets rubber stamped.
Do you have any information on the timing of this expert meeting?
Well, I mean, if it were me doing it, it wouldn't be any earlier than next September.
But that's exactly what the IPCC plenary said, I think.
Well-
September 2007, no?
The IPCC secretary said June,
Uh-huh.
but then it's someone else doing it.
For the expert meeting?
For the expert meeting, yeah. That would lead to the technical paper, right?
Yeah.
So in any case, I think as far as the chapter 3 is concerned, we can consider what we can do already for the next draft, or the third order draft, in this way. I mean, if we agree here that we have to look for two scenarios of this type, one high and one low, we'll look at the possibilities and make a proposal of what
what might be useful is to think about whether there are particular criteria that should be considered in making that selection.
well, one we already know, which is gridded land use. Or at least some treatment of gridded land use.
But when you're thinking about a set, are there, what kind of variation would you want across the
Yeah.
two, so that, or do you not want variation? I mean,
I-
that's a question to the
Yeah.
ESN models.
I don't know, from scenario point of view, the dilemma that I would have immediately is, whether those two cases are linked in some way or completely independent of each other. By that I mean, if the high case is, for example, based on A2 scenario and low case on B1, which are fundamentally different worlds, is that what we want, or do we want to have some more linkages onto socioeconomics? I don't know what the answer on that is, and I think we need to discuss this.
Right, although to some extent don't you want to do it so that you're not completely tied to a particular
Yeah.
socioeconomic world, because then you're getting away from the idea of modeler's choice.
Exactly. Well, you want to have 2 or 3 scenarios in each bracket that are consistent with the idea, but at the end we pass the information only of 2 specific scenarios.
This is, we're talking about
For clarity.
stabilization in
Huh?
general. These are stabilization scenarios.
Well, that's your input up
Yeah.
there.
Right, the high and the low end.
Isn't there,
One wouldn't be though,
isn't
right?
there
A2.
there's another dimension, right? So we've got scenarios that are defined by where they stabilise. But the issue of how fast you stabilise is another one, right? It's possible to overshoot.
No,
deal with that?
no. In this case, we have one scenario that actually doesn't stabilize. That's the high one. But I mean, we can change that.
Yeah.
The way I understand the discussion so far, we have one very high impact scenario, which is then probably a case that doesn't stabilize.
Okay.
That the forcing continues increasing,
Okay.
who knows until when. And the other one would be stabilizing at a fairly low level, which we still have to decide what it is.
Okay.
Whether it's 4.5 or 3 or some in between. So those would be the two
And you
the
wouldn't.
2 extreme cases.
Okay. On the stabilisation scenario, would you also span some range on how you reach stabilisation?
Well, I think we already have in this set, and in the refined version of that, we would probably have 3 or 4 or 5 specific scenarios that do that will provide that range.
Okay.
But I would imagine that for the purposes of this, we only provide at the end of the day one trajectory with information about the span of the uncertainty.
One thing I've liked about this discussion so far is if you compare it to the runs that we did in AR4 as modeling groups, we had 3 future scenarios in that. And then we could run ensembles, of course, but we had 3 scenarios. In this proposal that we just made, for the folks that are running ESMs, there's 4. There's 2 for the high that you propose, 2 for the low. For the folks not running ESMs, there's only 2.
Yeah.
So, and I like this is the right number.
Okay.
We got one part of the answer right.
Then you can have some optional scenarios.
Pardon?
You can have some optional.
Well, there's always people can run
And that makes
whatever
sense.
else they want to
That
run.
makes sense from a social and economic point of view. I would be interested to see what is the impact of land use. So you can isolate this impact from the CO2 effect. So you could have one mitigation with intensive land use,
Yeah,
and one with much
and that's what I was trying to think, if there was a way of characterizing it. So one would have a much higher percentage of land in forestry and less in agriculture,
But
for example.
another way of thinking of that is that for each of these 2 categories, we have on the emission side ensembles as well, whereby we'll provide information about one particular trajectory, but the ensemble gives the range of uncertainty. That way, I think we can handle the issues you're raising. So you have both. You have multiple scenarios, and the communication between the 2 modeling groups is based on 2 particular reference cases.
Right, but could you, Naki, say, for example, in the high case, you would have a land use scenario that involved a much greater percentage of highly managed land?
I think so. Yeah.
So that, again, I'm trying to keep them to the
Yeah.
2 runs.
Yes.
And then in the low forcing, you'd have a much higher percentage in forests. Because again, you'd expect those
Yeah.
might be consistent,
Yeah. Okay.
even though they're
Then
arbitrary
you'd have
worlds.
a unique scenario of
Right.
land
And-
use associated with each.
Right, and you'd still, then you'd have some variation
Plus
for
an
you
ensemble
guys.
around it.
That's
Yeah.
quite nice. Yeah.
Right.
So you have a storyline associated with these idealised scenarios.
Right.
All sounds so easy. It's time to stop.
No
Well,
more
we'll begin to
questions.
think of all the things
If
that
we-
may make this
If we
not
go on
work.
for half an hour, we will find all the problems. So I think we should stop. Right? You've got one.
Problem
It's already beginning.
that I find with that cycle is that working group 3 has its own models to translate CO2 emission to CO2 concentrations.
Yeah.
And you go through that cycle to get the implied emission.
Yeah.
And you give it to the working group 3.
Yeah.
And the people in working group 3 would say, okay, if the stabilization scenario turned out ridiculous, kind of. But the working group 3 people would say, okay, it's ridiculous, but are you saying that the original emission scenario is ridiculous, or our median translation model is ridiculous? Which is
Well, I
the problem?
think, sure. I mean, I think if you found an inconsistency in that loop, then that would be very useful. Because basically it would say that you, based on the inputs to it, this is not a consistent scenario to follow. In some of these models, the feedbacks are so strong, you just can't stabilise at 450, for example.
Yeah.
And that's a very useful thing to know.
Yeah.
It would expose an inconsistency that says, for this set of assumptions, you just can't do it. So, yeah.
Don't you think that's kind of fair? That seems like that would be fairly likely to occur.
In some models it would.
That bad outcome.
Yeah, but that's an important result, though. I
It's
don't-
important, but it's not particularly
not
useful result.
necessarily. Huh?
It's important, but not particularly useful.
Well, I think it is useful
Well,
to know that
why-
some
yeah.
a particular scenario, there's a problem with this particular scenario being impossible to achieve without some major other mitigation.
As an example, on our side, for example, with the A2 scenario, we cannot go through the 3-watt stabilization in our modeling approach. We just can't make it unless you assume some absurd amount of carbon removal from the atmosphere.
There was a great phrase that one of the modelers used: "You're making your model do unnatural acts."
Yes.
I'll go back to the other possibility. The problem is that the simplified integrated assessment model is just the flaws there. It's not
Well,
that
in
you
a way-
can't do it; it's that
In a
model
way,
is
from my
incapable of
perspective, I
simulating.
don't really care how they come up with that concentration profile. I suspect it will look quite idealised.
Yes.
Okay, this concentration profile. And all I'd want to know is that the level's been set appropriately and that the rate is something that you would consider to be undamaging in terms of, say, impacts.
Right.
And that will be it as far as I was concerned. That's an idealisation. And then the subsequent thing is, given the feedbacks in the system, can you get there?
With that
And in some
model,
models you wouldn't, and there would be a PDF that says there's a risk you can't do this,
Right.
which should help policy.
And what you can do, if you design it right on the working group 3 side, is actually get modeling groups to perform different types of experiments to say what are the different ways to
Yes,
get to
to
that
get there.
trajectory,
Precisely.
and what are the kind of obstacles that
Yeah.
you've run into, which could then provide a useful feedback to RD&D.
Yeah.
We really need to
Yeah.
work on this.
Yeah.
But I don't know how you can conclude you
That
really
gets-
can't get there when
that gets to your issue.
that last step is just with this simplified model. I mean, maybe there is an emission scenario in the real order system model that would get you there. You can't conclude that just because that the simplified models can't get there, that you can't get there in the real order
Yeah, but
system.
okay, but I presume that those sort of things like the gradient of approaching stabilisation would in some way be chosen because of economic impacts of doing
Yeah.
it. It's like the WRE stuff was chosen to sort of in some way minimise the damage. And then you say, well, actually, you can't do it within this context. You
And
can't.
the physical
It's a
climate.
socioeconomic question more than a physical system question.
I
Is
don't see
that-
how you can. I don't see how we show that.
It's the inverse modeling and the
Yes.
sort of more detailed kind of modeling that you do from using the integrated assessment models. What are ways of getting to that trajectory?
Yeah, but you have huge constraints already. Like you've prescribed only one gridded land use. Who's to say there wasn't another gridded land use that would have helped a lot in the persistent?
Well, in that case, you'd hope to get it through the iterative loop then, right, George? So you come out of this and you say, okay, well, you just can't do it without land use. So there's a
And
mitigation.
then you pick
that might
another
help.
land use.
Well, that's my problem. Is
Yeah.
that you really are committed to this iteration cycle.
Well, I think you are. It's just that it isn't feasible to do that iteration within one assessment
With the
cycle,
assessment.
And that's my.
which is why it has to
Plus
be
you can-
staggered.
Well, there are always EMICs that you could go back at some of this with.
Sure.
That's where EMICs will come in really handy. They can get
They
back
help.
through the loop faster than you can with an IOGCM.
Yeah, but wouldn't we at some point, when we are so far anyway, sit together and look at the low stabilization scenarios that the emissions community has produced and pick the one with land use that looks most balanced from that point of view? Because there would be fewer alternatives. One can pick in advance something
Right.
that looks more reasonable rather than extreme.
But in the independent activity phase of this, where the IAM groups are simply doing their own modeling, modeler's choice, I don't think you would have to constrain them to the one land use pattern. You could still let
That's what
them,
I'm
just
saying.
as you guys are doing. You guys can also go off. on
Yeah, that's
some-
what I'm saying. There will be multiple land use patterns associated with each of the scenario category that we will be passing on, and one particular variant would be then chosen.
But there will be one set where
Yeah.
everything is consistent.
But the consistency, consistency is the key thing, and every time you go around the loop, you might change a consistent set, but every loop has to be consistent.
But I still think the problem really is that you're not going to go around more than one loop.
That's why I didn't understand.
In a given assessment, you're not.
In a given assessment.
It just doesn't happen.
So you're never going to get convergence. Like, you're never going to really close this problem.
Well, it
The
depends.
next time you come around, you've got newer system models, and you're really back at step one.
That's not unique to this
Yeah,
particular
that's-
problem. That's the same
that's
with every
IPCC phase.
system. Except
Well,
normally what
science
happens
phase.
is that we've got, because
Yeah.
they're not staggered, these guys are using stuff 4 years ago rather than 2 years ago,
Right.
which is...
I mean, I think your idea would really work if we could stick with a common Earth system model and go around this thing a lot of times.
It was too
I
soon.
think it would really work, but we're never going to do that. Right?
Well, not for a while.
I think we'll get, sure.
Eventually we will.
I don't think the feedbacks are so strong
I do.
that you're going to get major divergence.
It's testable.
We'll find out.
Yeah, right.
Naki, there's a thing I
We've
can
not
give you
done it
on a
before.
stick if you want. TGICA put together some preliminary thoughts, and we've said a lot of them, but it's down in one little table of what the criteria might be for thinking about which runs to pick or which profiles to pick. So I'll pass that on.
I remember the old.
I don't have a good
the
alternative
old
either,
table.
so
This
no,
is a revised.
Well, it was
Think
to
about
Seville.
Yeah.
the restoring approach.
You may have.
Yeah, I got to think
Allows
more
the
about
model
that.
to
It's better if you give it to me.
heavily inconsistent with the concentration scenario to go away from it a little bit. In some ways I think that might be a safer thing to do.
All right. We're down to, I think we've covered all the first 4 questions.
I think so too.
The 5th question has to do with ensembles and numbers of ensemble members. Obviously, for the historical stuff section of the runs, lots of ensemble members are needed for the detection attribution of folks, and they even like subsets of forcing so they can identify signals to a given forcing. But for the future, what would be, since I have no feel for how variable one run, from a physical climate system I understand, I have a feel for how variable one run to the next would be around that loop. But from the carbon side, how variable you think it would be going around that loop?
So you mean the carbon response to the variation from the physical model?
Yes.
How big is the variation
just
from
in
the
the-
physical model?
Or just a variation, you're just sampling the variability of the carbon. Vegetation itself, there's interactions with inside of it and with the climate.
I think that the variability in the carbon side is dominated by the variability of the physical climate model.
Yeah, I think that's fair.
So you get again. So
Okay, that's good enough.
we should need as many ensembles as you need.
Yeah, I think that's I agree with you. Go.
That's what you need more on some
about
to
thresholds?
go for low CO2 than for high CO2.
In some regards, it depends on what, but you're right. That point is correct. Although, I don't know anybody in practice that's actually done that. Usually if they run 3, they run 3 for all of them. If they run 8, they run 8 for all of them. Or if they run 1, they run 1.
How many are you going to run based on the physical climate system?
That'll vary from institution to institution. My guess is that GFDL will run 1. We've never seen much value in running multiple ensembles for the future. For the historical, yes. But for the future,
What's the difference between why is that?
Historical is to do with
it has to do
attribution
with
change.
signal and you want to beat down the signal and noise.
Attribution of change.
Yeah, with the future ones,
Aren't you going to want to do that same attribution of change going forward?
We haven't got any data to attribute against.
defining. This is now getting to be philosophy, but defining the signal for one of these uncertain future scenarios doesn't seem to be that important for what we've been up to.
Because the signal's so bloody big, that's why.
And it's big.
It's another way of saying we're all going to die.
That's of course assuming that you want to put a lot of effort in the regional and some of become more important.
I think we would get regional climate change a different way by doing time series.
Well, you could
Yeah.
yeah.
It's a different.
But I think that's That's a
It relates to
physical
physical climate.
But it's like I said, this philosophy varies a lot from
Yeah,
modeling
physical
group to
climate people
model.
may not know that.
We did one, NCAR did 8, I believe.
You guys bracket that.
So we actually
Thinking on this?
we bracket the thinking on it. So.
Basically 200 G away, you
We should be both curious.
probably equivalent to
Well, so there was a certain amount of pragmatism in both of
which is
them.
equivalent to
Also.
I see the pragmatism on your side. I don't see the pragmatism
On
on
NCARs, it was a lot of those 8 were run in your simulator, so they had the time so they could run them. Once you made the commitment to run them over in Japan, it was easy to run 8 as it was to run 1.
It was only really 3 or 4 though, when we
overestimate
3 years.
or underestimate the instability of the system.
But maybe it would be good to use to find that you did a lot of different ensemble to see if it was worth
doesn't matter.
doing
Yeah.
it. Because using this experience to see how much would be necessary.
Is that does the results from doing the 8 bear out what Ron said about they're not much different or something like that?
There's variability.
I think it depends on the question you ask.
Yeah, exactly.
I don't
I'm
know.
not saying the signal's so
That
big.
gets back to your list of diagnostics.
Okay, it's not an issue for stabilisation, I don't think,
No.
because you've got a fairly long period where CO2 is stable and you're sampling variability anyway. It's equivalent to running ensemble numbers by having temporal variability in one of them.
Actually, since we're not going to solve, I don't think we're going to solve that particular question since it does vary from group to group. The groups have actually thought about it. The answer that I like to hear was that there's no additional considerations coming out of the carbon cycle side.
Well, the only way it would happen is if you initialise the ocean differently. We've got no plans to do that.
Well, that's the next question. The last one was the initial conditions. And we've talked a lot about how to do that loop. What the start dates were for this. And one thing we haven't talked about the start date for the scenarios. Because, as Jerry pointed out, that was an issue in this particular go-around.
Well, I mean, to respond directly to that, right now the base year is, in most of these models, is 2000. Some is still 1990, updated for year 2000. But the problem on our side, the way I see it, is less the base year and more the fact of the variation of the parameterizations between the models. In other words, the difference in the base year calibration of different models is larger than if you choose a different year. It's a bigger error. And for example, in SRS, that was dealt by what we called, I think we called it standardization. I forgot which word we used, where all of the models were indexed to the median over the next decade or two, and then smoothly could diverge. Consistent with their
Harmonization.
But there's
no, harmonization was something else. That was population, final energy, and GDP.
Okay, I'm sorry.
How far that should vary across the model for a
Why
particular
does this matter to us? I mean, the uncertainties in the emissions, right? It's not the concentrations they're measured.
Well, I'm talking about the emissions now, but
Yeah,
when
but
you
that's
go
an
to
issue for you,
concentrations,
yeah.
that gets smoothed out.
Yeah.
So this base year problem is a less of a problem, and I think we'll have to worry on our side as a model, emissions community. How do we report this to you? Do we go with individual trajectory from a model,
Right.
or do we take some median of the model sets to avoid this problem? I don't know what the answer would be, but I think it's solvable because we've already solved it once. So.
But we don't need the emissions from you. Under this model,
Right,
this
we don't
experiment,
need
we don't need the emissions. That's your problem.
You just need concentrations.
And the
You need concentrations, yeah,
and the concentrations are measured up to the current day.
and the concentrations are smoothed out, so that's what I'm saying. The
Oh, okay,
problem is a
all right.
little bit lesser,
I see. So
lesser of an issue.
we might have a discontinuity between your smooth concentrations and the measured ones doing this.
Yeah, well, I mean, we can link our concentrations to the historical concentrations. We
I see.
wouldn't start at one point.
I see.
We don't do that anyway. The question is just, how many of the gases, how far in the past we treat, and so on. But
Right.
CO2 is the main issue,
I
the way I see it.
So we just wanted to go through 2013 or something.
Well, we won't, when we're running the models, it'll be 2009.
Okay, yeah. I don't think it's such a big deal.
Yeah, I think we can decide that afterwards, as long as we agree here on the basic principles. Because I could imagine that most models emissions models could report concentrations from 1850. Given on the historical data, land use is always the biggest problem. How do you decide? But energy is less ambiguous.
And then the other issue, kind of circling around with the initial conditions, is now on the ESM side of things. Goes back to what we talked about at the break on the, for a control climate. Say, this is a climate where the irradiative forcing is constant. Typically 1850 plus or minus 20 years. Do we want to have any limits on how stable the PCO2 is in that control integration, or suggestions for how stable it should be?
Yes. And the way we did it, we had a quality check on when we were developing the couple model, which is that it needed to be the balance. In other words, the drift was less than a tenth of the current fluxes, okay, as estimated for the IPCC for the 1990s or something. So the drift is less than 10% of the signal for the current area.
That's what we picked also.
It's quite tough to do, but and you have to take long integration periods because there's a lot of variability. But
so that's something like a petagram or a tenth?
less than that, isn't it? It's about well, it's 0.2 in the ocean, 0.2 on the land.
0.2, right.
But the net flux stuff. Yeah.
Yeah, the
10%
imbalance.
of the
Yeah, so the drift in the atmosphere could only be 0.4 gigatons a year, and 0.2 in each separately. So you've not got a siphoning effect where the atmospheric CO2 is imbalanced, but carbon's going from ocean to land.
What happens if a group doesn't hit that target?
I think you have to.
They should just report it, I guess, and then that can be evaluated by the IPCC chapter. That'd be one way to go at it. If a group decides they want to run the run anyway.
Are there any hard kind of barriers to clear with the physical plant models?
Not in terms of participation after the fact. In my talk, I gave an example of somebody whose thermal analyte circulation died, and then they weren't included in the mix.
Yeah.
But not beforehand. There was an expectation beforehand that if you were going to participate, you should have made all the runs.
Yeah.
And provided there was classes of data types. Some were mandatory, some were optional, different levels of optional.
So it'd be like a guideline, and you would have to report what your imbalance was.
Yes. That's what I was thinking.
It's fairly, actually, you wouldn't even have to report it. When you send your results in, you'd see the fluxes, wouldn't you? You'd add them up and think, oh, no, that doesn't add up to zero.
Right. I just want to make sure that that information is flowing.
Yeah.
If it's going to be used as a criteria at the end
Well,
of the day, it'd be nice that the groups would know what it was before it was started. I just didn't want any surprises. So if it's something that's going to be, evaluated, then we should let it tell them that it's going to be an evaluation criteria.
Are the control runs, physical climate models control runs, given over to the IPCC at the same time as the scenario runs?
Absolutely.
Okay.
In fact, typically they're first because they're done earlier.
Right.
Since it's sequential, to run the historical out to into the future.
And we do the same thing with this then, except you'd be reporting in models that are ESMs also the carbon fluxes.
Yep. Yeah, so somebody's going to have to come up with a list of what things to be archived in common, which is not a non-trivial exercise. But that has to be done.
Well, maybe we should just say that needs to be something that should be done, maybe even in this next process.
Yeah, it'll be an attempt. The last time of the four major components in the physical climate models, the atmosphere went by far the best because of the long history of AMIP. And then maybe the land was second, sea ice was third, and the ocean was worse, just because there's never been an ocean modeling or comparison project.
And that list should be, I mean, there should be impacts people involved in just thinking through that list too.
Yep.
So that we don't go through a process of leaving out something that they think is important, you know, for some of the offline modeling, and then have to go back and try to add it in later, which is just hugely more effort.
Yep. Those are both good recommendations. Yep.
Keep track of everything.
I'm sorry, it's going fast. If you need, on those, I
The
think I can
steam is
help
coming
you.
out of her ears.
Like I say, on those, I think I.
Could you reiterate just quickly for me? So I've been trying to follow everyone's conversation.
Okay, for the data side, there needs to be a carbon list developed, variable list to be archived.
Right.
Okay, for all of the components, there needs to be more or broad community participation in developing these variable lists, and particularly from the impact side, which was missing in the last go around. Is that fair?
I think so.
I mean, somebody was sitting there in the room at the time. I didn't see. I was worried about it, but there's nothing we could
Well,
do.
there were, as I recall, there were a couple of things that ended up not being archived, and when we went to set up the DDC data set in Hamburg, we had to go back to PCMBI and ask them to go back to the modeling groups. And it was often, plus there was the usual crime of whaling and national. We were there!
They were. I agreed with that at the time. It was a known problem. There's nothing we could do. It's kind of haphazard under the gun.
Well, and I wonder about this Amazon problem that
Okay. Is there anything else you want to bring up? Hey guys, anything else?
Do we want to talk at all about a strategy for scaling?
Scaling what?
For mitigation versus scaling for impacts, and how we might actually want to take this a step further from the business as usual to coin a phrase and package some of the results for risk assessment.
You mean spatial scaling?
All kinds of scaling.
I still don't know what you mean by the word scaling. Yeah, that's what I was just going to ask. Downscaling?
Yeah, I think so. How do we actually package this in a way that's appropriate for mitigation or risk assessment?
For use in?
Those
So
kinds
that
of
this
activities.
has.
This is thinking actually pretty far beyond AR5, but eventually we're going to have to start thinking about these kinds of things. How
But I
to
still don't know
package
what the kinds of things are. That's my problem. I don't know. I don't know what you're. I don't know. What
some of the how to package the results of both the combined scenario and output for risk assessment. Some of the things that Richard was alluding to earlier this morning.
Is this a post-processing thing?
Yes.
So it's
Yes,
you know,
yes,
if you knew there was a
definitely
threshold, you
post-processing.
could
Oh,
look
okay.
at the talk time scale
Sorry.
variability
Yeah,
and say, well,
that's what I didn't understand.
I mean, some of the models want 6 hourly data for some variables, and obviously you're not going to do that for everything. So do we have to develop a strategy where we look at a few time slices going through the century? I mean, we've done that sometimes to cut down on.
Well, another way to say the same thing, I think, was brought up during my talk. Folks were complaining about how the data is organized. In order to get a point's worth of data, you got to get the whole field.
Mm-hmm.
Yeah.
And there's issues like that. But those issues, I guess I would recommend the way that those issues be solved is that there be data distribution points for various activities. Because it really, you have different communities wanting the data in different ways. And the technology is such that you can't do it as a technology solution. You actually have to reorder the data.
So you have a center for study of
Working with
hydrological
Well, in some sense, you have a working group 1 group and a working group 2 group and maybe a working group 3 group.
Yes.
Where that's getting model data
Right, or you might be able to do the working group 2 and 3
together.
because I think that a lot.
Yes and no. Precisely because what you said before is that working group 2 might need lots of detail on various time slices, whereas working group 3 will probably have quite a lot of emphasis on spatial detail and temporal paths. And my experience was that working group 2 usually needs a huge list of variables that are
Well,
partially derived from climate models and partially from the scenario.
I'll be a heretic and say I think sometimes there's more requested than people sometimes know what they want to do with it. But
That's always the
Oh, you mean it's a backstop?
didn't
You
hear
just
that
request
from me, I
everything.
guess. I'll say that off the record.
You can quote it to me. I've said it many times. I've been guilty of it a few.
See, but the philosophy is, well, I'm asking, I may as well ask now, rather
Yeah,
than
sure. Give me
come
everything
back.
you've got and then a bit more.
Yeah.
Right.
I'll see if I need it later.
But that is an important issue for how to distribute data so that it's accessible by a wide range of users.
And I'm happy to have that come in specifically to something like TGICA to work on.
And that
Yeah.
that involves all sorts of technological and web software and people interfaces.
Yeah.
So
I just
That's
kind of
a-
wanted to bring it up as a.
that's a good issue.
It is a very important issue.
So altogether, it seems to me that there are two separate but related issues. One is how the information is passed for this exercise between the two communities, and the second one is what information needs to be cataloged and how for the use of other communities.
And that may not be solved in AR5, but it's something that.
Moving target.
Moving target.
It'll never be solved.
rolling
It'll
target.
just get better.
Evolve.
And hopefully
And
not
more
worse.
demanding of
I think we're done.
Okay.
Unless somebody's got something else to say.
I think I've got, well, I started, I think I've got pages of notes. So.
Yes.
Well, that's what I was about ready to say. The three of us could do right now is do a sort
Yeah.
for a little while. If you don't,
Yeah.
No.
so the rest of you are
We're free
see you
to
at
go.
4 o'clock.
If somebody has a wood on a stick.